Hello and welcome. This is going to be on chapter 3 of Linux Basics for Hackers. So this one's is a pretty quick chapter on configuration within Linux, but I wanted to go a little bit, take it a step further, because let's say you're watching this and you don't know any idea about networking itself. So I'm gonna get like a basic water down with my notes I've took from TCM Security and kind of explain how this works. I've been doing IT for about 7 years, and more than likely, I'm like, this is what this does. So we'll start with IP addresses. So IPv4 is Internet Protocol, and then also IPv6 is the same thing. Is a version of the Internet Protocol or IP, which is underlying the protocol that enables communications on the internet. So basically, if I wanted to go to Facebook, this is not just going by the host. I'm going to do a whole web, how the web works later. But I want to connect to that website. The website is containing some kind of IP address, right? So usually we look at it when we sign in or we grab a website to go to Facebook here. Like, let's give you an example. Let's just say Yahoo. Or if we go to Yahoo, we're essentially see the domain name, but we're going to a IP address that's registered under a DNS record. So to separate from doing a bunch of just IP numbers where we just use the domain name instead, but we're technically signing into or we're communicating to or towards a IP address. So um difference between the two, this one's longer, this one's not. Um at some point we talked about like I think like the going joke was this is supposed to replace this one, but it was way too long. So that didn't work out the way it wanted to. But you still can use both these two. More likely, you're going to be in the field and with networking or anything that has to do with anything at all with IT itself. You're going to use IPv4. So, like setting up a printer or configuring a DNS or a switch, it's all going to be under this traffic. Uh, Not just traffic, but these under this 30-bit numerical address that represents a dotted decimal format. So it consists of 8 bits, ranging from 0 to 225. This allows also like 4.3 billion unique addresses to use as well. So if we go down here, there's a different class structure. I'm going to go here to explain a little bit easier. So consider this being class A. This is going to be your local. I've seen this more on the DMZ. And then I've seen this more on the local. So like local meaning on LAN, and then actually just bring it back up. Well, this would be LAN, in a sense, or wide area network, range network, and then local range network, basically. You could use this in a LAN setting. I haven't seen it that way, but um, definitely not recommended. But let's say, like, I went to Yahoo, right? This is technically like if we go with cloud computing or just in general, my address is trying to talk to that one. We'll talk about the OSL model in a minute. But when I reach out to that website, it's getting to it's using something like this or something else too. Wait, because we can also look up the MX record or the AA record. Any of those domain records we can look up and to see what IP address is going to use. And technically, like wise, it doesn't really matter. But I I communicate to server. I am customer. I use Amazon. I am on Amazon server, and then anyone needs the help with backend that's going to be locally that can connect to that server, if that makes sense. So that's how they're interconnected. This part's going to be dense. Subnetting. Try to give a basic water down of what subnetting is. So Under the class center domain routing or CIDR, the notion of using a method to represent IP addresses and their corresponding subnet mask, it is signifies a network prefix length, which is indicates the number of bits using of the network protocol of the IP address. So I learned that this is probably like the power of two or power of eight. I can't remember which one. So down here, this one makes sense. So the ones I've seen the most is probably, oh, come on. And then 32. Now, 32 is an exception. We'll get there in a second, but I've seen more of these here. So using the Cybermentor's sheet here to explain subnetting because it's very, very dense and I might not talk correctly on it, but uh, the more subnets you had, always subtract two from the total host, that's for sure. So the more like the less subnetting route, like if you do 192.168.0.0 with one, you got like over 2 million hosts that you can use. You might not want to do that for good reason. So, because the more subnets you have that's open, the more accessible that you can use these IP address. And also, does your company need over 2 million subnets for their network? No. But it is that option basically. So the more that you've used the number, the basically you keep going down the list, the less the numbers will get. So more than likely in a environment, in a host environment towards any company, they're going to use a oscillate of negative, oh sorry, oscillate of 24, not negative. I apologize. So that means I have about 256 hosts that you can use. This is more the actual scenario that I see on a daily basis. 16 is kind of an exception. It depends on how much you want to use. And then 32, when I brought 32 up because it's sometimes an ISP would give you a static number, and this is the static number you would use for um that one record. So like let's say your DNS record and you're using you only get the one versus like five. Well, in case, so you're going to go ahead and when you do the record, you're going to go ahead and give that number, like give that full number completely, and also by 32, it means only that one host IP address statically works for that one account. Versus 16, you have 65,000, like over 65,000 or more, and a little more, and some change. And then 24, you have about 256. But this is the more likely you see when you get on an actual corporate network. Yeah, that one is a very hard concept to to understand, but you're more likely going to see the 24 part. So that brings us to the OSI model, and I'll try to best explain here. So you have the physical layer, you have a data link, you have your network, transport, session, presentation, application. So in the sense of with networking, you have the physical layer. So I connect LAN to modem to switch. Basically, uh, yeah. So I it's all physical. So I put LAN to modem, I guess to router, like any of the hardware, it's a physical layer, basically. And then the physical address would be your MAC address on any of your stuff, being like your PlayStation 5, on Xbox, your computer, anything that connects to the network has a MAC address. So that also includes you can do the VLAN, basically to separate out networks uh, under your oscillate too. And then the next one is networking, where that's where the IP address lives. I wouldn't say live, but yeah, that's where it communicates with other devices. So if I wanted to go ahead and communicate with my PS5 and actually just scan it with my computer, I can do that. I just have to find out what the IP address is, and once I got it, I got it. That's kind of That's what the network layer would do. Transportation would be the TCP and UDP, and then also the other protocols that goes with it. And then that's your end-to-end connection. And then your inter-host communications, your session is basically if you pull off RC or CE or remote code execution. So then you can establish a connection with those protocols. And then presentation is data being presented encrypted. So this would be like your HTML, other stuff too that you send in. And then application would be what you're seeing now with Notion or Kindle. So this is the application part. So to remind to remind myself here, and this is kind of my own notes, please do not throw away sausage pizza. Oh, sorry. Please do not throw sausage pizza away or the OSI model. Now, in this case, this is what I usually do is I'm sniffing, or I could use land turtle if, if we're thinking about the attack. And then, oh, depends on sniffing, but yeah, a land turtle would count as, or a shark Ethernet cord. Some of those are pretty cool from Hack 5. So any of those like physical ones that you can use, and then spoofing would be max spoofing, max flooding, and then VLAN hopping. And then you have man-on-middle attack too, and then this is the transportation layer. This is where TCP hijacking DOS attacks happen, and then there's the hijacking attack, which would be cross-site scripting. The other malware, and then layer 6 could be considered phishing because you're trying to get credentials because you're presenting your email to somebody, and then 7 could be the exploit because these exploits could be on the website itself. And then this is how it for layer 2. This is how it would typically work from a packet. TCP packet comes in, uh, finds MAC address, and then contains what port it is, and then goes to data. That's how a packet would work. So I hit MNAP. I'm hitting all these layers here on one packet on. That brings us to the three-way handshake. I'll start from the bottom. So no, I'm not going to start from the bottom. Excuse me. So transmission protocol, control protocol, and user diagram protocol. This is brought up in the interviews. And this is also why I wanted to add this content before we go to the next chapter. Is a lot of people don't know the difference between the two. This easy way to remember, connectionless is what UDP is. This is the three-way handshake. So this one provides a relatable and clear, ordered and error check delivery system of over packets over the IP network, and then UDP is a connectionless protocol. So then the three-way handshake is processed by TCP to establish between the two devices, and this is basically how this one works. So you have your SYN that sends the packet over and gets flagged, and then yeah, it acknowledges it, so it sends back to you to acknowledge, and then sends back again, finally to the machine that you're talking to, that creates that handshake again. So think of it as here. Three. Yeah, that was perfect. Oh, come on. I want to get on to Facebook. Facebook acknowledge that I know it. I want to make sure that who I am, I acknowledge back to the port I'm on Facebook, if that makes sense. That's the best way to explain the three-way handshake. And this handshake happens all the time. You can see this in Wireshark too. That brings us to common ports and protocols. all you could stop here to grab whatever you need for the most part. But when we go over on doing boxes or so that I'm looking at, these are common ones to use. Not every single one of these will be used in an actual pen test. It depends on how you get in or how the scope works. So these are just the basic, like, hey, this is what this is. So SSH is king. No one uses Telnet anymore. That is not encryptionless. I mean, sorry, it's not encrypted. It doesn't have encryption on it. You can see anyone's connecting to it on through Wireshark. We shouldn't be using port 21, but in case it does, and you're using FileZilla, it is being seen. Um, More than one nowadays with um not just port 25, but it is used port 25. You have a 398. Sorry, is LDAP. I'm going to recover there. 539 and 565, 465, 465 and 539, 538, 539, I believe is the, and then 225, 225 is the mail protocol. So there's more than those you can use. Um, SNMP is the UDP protocol. We all know RDP. And then SMB, this is connect if you have a shared drive in your company, this is what you're connecting to, such and so on. Well, those are just the basic ones. And then MAC address basically is just your whole thing anyways. I'll show you here. Now we can probably get to chapter 3. Wanted to give that as a little heads up. So, don't do this to me right now. Don't. All right. So this one, I'm not sure is safe at the moment. I'm gonna stop sharing my screen. Hold on, let's see. Sorry about that. I just have to check something first before I assume something. All right, now it's safe. We're gonna close the book out. I have to do the leak. All right. So getting to the nitty gritty on the commands for Kali though. So if I wanted to view what IP address I have on my box, there's a couple ways of doing it. There's if big tells me what IP addresses I have, and you're more likely, here's your Docker one. Docker also uses class B, but for mainly what you're going to use, or majority of the time, is going to be Etho or Tom or Tune when you ever connect to a VPN, like Ton0 or whatever the VPN is going to be called. But that's it. The other way you can do it too is IPA, view all the addresses you have, and you actually get to see it in color. I feel like that's easier to use. I prefer this method. That's a couple ways of doing it. Then you can check the wireless network too. I config, but if you don't have a PC that already has like the image built into the machine, like let's say I put Kali on an actual box, not just on a VM, this would be here, but there is no wireless connection because it's a VM. So if you wanted to change it, your IP address though, you can go etho and then do whatever here. Whoa. All right, I'm just gonna if config again, etho, eth. If you wanted to change it that, you could with that command. I'm not gonna do it because I don't with VMs you don't really need to. Unless it's like you've got to do it for some reason. But more than likely your VM that's already set in the back end is just fine. So you can also set the subnet mask too if you go to net mask here. So if we try to do that again, big 0 again there. Uh, so this is where so this is no different than saying that your subnet's going to be block 24. This is just the what it would look like. You add it, and then you can broadcast the whatever switch or add in what the gateway is going to be. So your gateway will always be the oscillator you're going to use is going to be number one. That's why you want to reserve two. So your back end switch is going to be the last was reserved to the last one to two, well, I think it was 256, but most likely you're not going to use that one. Your other switches are going to go like bottom to up, like 225 to 255, and then 254, whatever. Whatever many switches you have, you're going to go backwards because those will take precedence instead. So, spoofing your Mac, you can actually spoof it with using ifconfig etho down, and then you can also change it or whatever, however you want to use it. More likely, that would be in case of doing like a red team engagement where you want to spoof it to like a phone or whatever. In this case, I'm not going to do it because this is just a VM, but I wanted to talk about it because it's pretty fun to do here. So all along. So that's what you would change it to. So yeah, so this is how you would switch your Mac, and then you can press pause here if you wanted to go grab the commands, or if you have the book, this is what it would look like. you would run this, and then you would change it to this, and then have it up. Because you want to, when you want to change your MAC address, you want to make sure it's down so that way it's not going to be broadcast. The goal here is to spoof off a device. Like, let's say you're in an engagement and you find a client has a backend networking product that can detect almost anything. So in this case, during a red team engagement and you have a computer that is, or a VM, you want to change the MAC address on it. So that way you could spoof it and remain anonymous. Those are what those commands would do. It does kind of come in handy in an engagement. You can also assign DHCP addresses with the DCH client. I guess that's not. Oh, that's a command that he put on there, but that's fine. And then you can see it. And then you can also run dig for domain names. Here we can go hackers. I'll just use what he has. Rise. So we want to look at the NS record. We can do that. We can also do it with the MX record, which is the mail record. We can also do AA, going from the AA record. We can also do the triple AA. Those are the records that you can see that you can look for within the domain name. And then different types of it too, which is nice. So you can also add a domain by going name server or echo name server. Use Google, for example. There. And then you do it. Oh, this command wouldn't work because I'm not using sudo, but that's what that would look like. You can put name changes in that configuration file, and then you can do leaf pad. But honestly, I do this instead. Like you probably seen the first command would be sudo, host. And then here, if you have a host that will work with, you can go like 192.168 dot server 1 would be, and then here, this is what you would put the domain name or server name, or like, I won't save it. Basically, during an engagement, this is quicker than I think we've had. You could go into the file and add the IP address towards your host file, so that way you can communicate with the server internally or externally. It just makes it easier. And if you're doing like Hack the Box stuff, anyways, you're going to be doing that. Oh, I know Hack the Box is very adamant on like adding the host on it. In some cases, you don't have to, but during engagement, it's more likely you need to. And during my last engagement, I had one on, so I didn't on this box. So I tried to use Hyper-V, but it's not a big deal. But any case though, you would save it, and that's what it would be, and then oop. No, that's yeah. So that's networking as a nutshell. And yeah, it's a very dense topic. I want to thank you guys all for watching and continuing on your journey. Like and subscribe. Thank you.